Hello Math 1093. In this video we're going to talk about graphing the tangent function. So hopefully by now you've seen a little bit about how to graph the sine function and the cosine function. Now we're going to focus on the tangent function. Alright, so the way of thinking about tangent that we're going to use in this video is that if I mark some angle t, or some angle of measure t, like that one. So let's say that has measure t. Alright, that's the same as saying, since this is a unit circle, that's the same as saying that this arc length here is t. Okay. So anyway, if I mark off some angle of measure t, what is the tangent of t? Well, the tangent of t by definition from class is that tangent of t is equal to sine of t over cosine of t. But let's actually rewrite that. So we know that the sine of t, if we're on the unit circle, is the y-coordinate of this point, x comma y. So that means that sine of t is y, and the cosine of t is going to be x. And that's actually true. This is something that's true even if I'm not on a unit circle. I can always count on this, that the tangent of t is going to be the y-coordinate divided by the x-coordinate. So we're going to use that in this video. All right, so let's look at this particular value of t. If I were to mark off a triangle here just to help accentuate what the x and y coordinates are, well, this would be the length x and this length would be y. In this case, the ratio of y to x, that is this value, is going to be somewhere close to 1. It may not be exactly 1. It looks like in this picture y might be a little bit less than x, in which case this ratio would be a little bit less than 1. But I could actually mark off a point somewhere over in this graph that illustrates that has the appropriate value of t and then a value of tangent of t that is a little bit less than 1. So that's the way we're going to approach this. But we're going to use a few special angles in this video in order to help us graph this accurately. So let's first start by talking about what happens when t is 0. So when t is 0, well, that means I'm right here at this starting point here, and my y is 0 and my x is 1. So y over x is equal to 0. That means tangent of 0 is equal to 0. So I'm going to mark a nice big point in my graph right there. And in fact, let's just think about some other places where we might expect the tangent to be 0. Here, for example, here y is equal to 0 and x is equal to negative 1. Still, we're going to have y over x is equal to 0. Now that point there, depending on how we got there, I was thinking of going there by starting at 0 and then traveling around counterclockwise. That's a distance around the circle of pi. That's an angle measure of pi. So at pi, I'm going to mark off another point, pi comma 0, because the tangent of pi is also equal to 0. And if I were to go all the way back around the circle, back to the starting point, I would end up with another place where the tangent is 0, because again, y is 0. All right, so it turns out at 0, pi, and 2 pi, I'm going to have tangent equal to 0. That's also going to happen at negative pi and at negative 2 pi, because, well, what's negative pi? I'm just starting here and I'm traveling around clockwise until I get here. And there y is 0. So y over x is going to be 0. That means the tangent of negative pi is 0. And if I travel around another half rotation, that's negative 2 pi, there I again have y equals 0. All right, so now I have a bunch of points already on this graph that are accurate. Now let's think about what happens to the tangent function as I go around gradually in this direction here. Okay, so what's going to happen if I move up a little bit? Actually, let me put in another picture of the unit circle just so I have this to work with. So let me move over here. I'm going to add another image. All right, let's just move that over. There we go. All right. So I'm just going to draw a few points here. Let's take a look at this point. If I'm at this point, so this is a point where t is rather small. It's a little bit greater than 0. Okay, so when t is, I'm just going to make a table here with my reasoning in it. When t is a small positive number, what's happening to x and what's happening to y? And then what's happening to y over x, because that's the tangent of t. Okay, hopefully this will help me keep track of things. Earlier I was trying to do this. I actually redid a bunch of the video because I didn't done all this writing down near the circle and it was just a huge mess. So anyway, if t is a small positive number, then x there is going to be approximately 1, because remember, this is my point x comma y, and there, x is pretty close to 1. And y is a small positive number. It's just a little bit positive. So if I divide y over x, I'm dividing what? I'm dividing a slightly positive number by 1. That's going to give me a small positive number. Okay, so I can mark that in my graph. If t is a bit greater than 0, then I get a small positive number for tangent of t. All right, what about if I go halfway to the vertical axis? So I go to this point right here. So in this case, remember, a half rotation is pi, and then this quadrant of the circle, that's half of pi. So this is going to be 1/2 of 1/2 pi. That's pi over 4. So when t is pi over 4, or 1/4 of pi, x and y are the same thing. They're actually 1 over the square root of 2. In case you don't remember that. That would be a good thing to try and remember. Useful to know. So that means that y over x, since y and x are the same amount, tangent of t is equal to 1 exactly. So when I'm at 1/4 of pi, right here, I'm going to be at the point, sorry, I don't know why I marked that point. In fact, let me just cut that off there. Okay, now, my tangent of 1/4 of pi is going to be exactly 1. Okay, what about when t is a bit less than 1/2 of pi? So like somewhere around here. So if that's my point, then x is a small positive number, and y is close to 1, which means y over x is going to be 1 over a small positive number, which means that's going to be a large positive number. Okay, so that means that somewhere around here I'm going to have a point where the tangent is quite large. And in fact, if I draw that point closer and closer to 1/2 of pi, that number gets bigger and bigger because x is getting smaller. The thing I'm dividing by is getting smaller, but the thing that's getting divided is still getting close to 1. So what's going to happen is as t approaches 1/2 of pi, my graph is going to approach positive infinity. So this graph is going to approach a vertical asymptote at 1/2 of pi. By the way, 1/2 of pi, what's happening there? If I'm at exactly 1/2 of pi, let's mark that point on the circle. When t is 1/2 of pi, my x is 0, so it doesn't really matter what y is. This tangent of t, y over x, is undefined because you can't divide 1 by 0. Okay, anyway, let's see what happens if we move t a little bit past 1/2 of pi. So if I'm over here, let me just move this up a bit so I have a bit more room to write. So when t is a bit greater than 1/2 of pi, my x is a small negative number, and y is approximately 1. Not exactly 1, but close. So if I divide 1 by a small negative number, I get a big negative number. That is something that's very negative. So I'm going to get a point on the graph that is somewhere down here. T is a bit greater than 1/2 of pi, and the tangent of t is very, very low. Okay, and remember, this graph somehow has to return to this point here. And it turns out if I go around this circle, or this quarter of the circle, my x is getting more and more negative, but y is getting smaller and smaller while staying positive. So that ratio between y and x is going to remain negative because over here, my y is always positive, and my x is always negative. So in this quadrant, tangent of t is always going to be less than 0. It's just a question of how much less than 0. So my graph is going to look something like this. Okay, and then in this quadrant, well, y is negative, but x is also negative. So tangent of t is going to be y over x. That's going to be positive. So that means this graph is going to continue into the upper half of the plane, and I'm going to have positive values of tangent of t. And then when I get to, let's mark that in blue. When I get to 3/2 of pi, this is another spot where y is -1, but x is 0. I can't divide by 0. So I'm going to have another asymptote there. So the graph is going to approach this asymptote here. And it's going to look like this. For pretty much the same reasons as what happened in the first quadrant. Okay, I'm just going to mark little arrows on there. And then after that, in the fourth quadrant, y is going to be negative, x is going to be positive, So tangent of t, which is y divided by x, that's going to be negative again. So I'm going to come back down here and return to 0 at this point. And then everything repeats, because after 2 pi, we're going to do the same thing as what we did when we came out of here, came out of the origin. So this graph is periodic, and actually can be thought of as having a period of 2 pi, but the period's actually smaller than that. We can actually think of it as having a period of pi, because you'll notice that what happens between here and here, between 0 and pi, it's exactly the same as what happens between pi and 2 pi. Okay, and in fact, I can extend this graph backwards as well, using the same reasoning. So I'll have asymptotes at negative 1/2 of pi. Sorry about that. And at negative 3/2 of pi. Any place where x is 0, I'm going to have a vertical asymptote. And my graph's going to look like that. Anyway, hopefully this gives the idea. Okay. So we tried to be pretty careful about what was happening in the first quadrant, but after that we use a lot of ideas about just what's happening in the other quadrants being very similar to what happened in the first quadrant. All right, so anyway, that was a bit long, but that's the graph of the tangent function, asymptotes and all.